Okay. This is a review lesson on recursive and explicit functions. This is the main thing that you got to get out of this unit. All right. A sequence. So a sequence is just simply a list of numbers that are linked together by a rule. So there's a pattern that happens, right? If you work out the numbers, or if you work out the rule, you can get the rest of the numbers in the sequence. For example, 2, 4, 6, 8, 10, and these dots represent that it's an infinite sequence and it keeps going forever. And here you see the pattern that could come up out of here, right? So you can see that, oh, it's times, this one would be times 2, maybe times 3, times 4. And you could produce the rule out of that, which would be this. So the rule for this one would be f of n equals 2 to the n. So that's the pattern. And this would be more of a explicit, and I'll talk about explicit and recursive in the next slide. But let me let me show you what I'm talking about here. Okay, so in this rule, if the rule is 2 times n and you're trying to recreate the sequence, if you are trying to get the first number in the sequence, you would plug in 1 right here. Inside the n, you would multiply by 1. So this would look like 2 times 1 would be 2. If you want to find the second number in the list, you would plug in 2. That would be 4. And if you're trying to find the third number, you would plug in 3, so that would be 6. And you follow that pattern. The domain is the term's location. So what first number, second number, third term, that is considered your input. That's what goes in. That's what goes into the n. And maybe from algebra 1 you remember range. So range is the f of n, and that's what comes out. That's the output. So the answer, like 2, 4, 6, 8, this stuff over here would be your output, and this would be your input. Okay, this is just a little review, and this is the basic information here. Go ahead and before I go to the next slide, if you need to take a picture or write something down, the main information is coming up right here. This is just the definition of a sequence and just a quick example of a rule. All right. Oh, okay. First explicit functions. There's a lot going on here. So explicit functions is a formula that allows you to find the nth term of the sequence by directly substituting known values in the expression. In this side over here, you have the arithmetic example or the formula. And on this side over here, you have the geometric formula. F of n is considered the current term. F parentheses 1 is considered your first term. D is known as the common difference. N minus 1 is 1 less than the term number, which is different from, which is not this. F parentheses n minus 1, when you see this notation, this would mean previous, and this would tell me this is recursive. So, so it's a little different. So it's n minus 1. Geometric, sometimes you're going to see it like this with a little n here, a little subscript, or you could see it like this. A parentheses n, or a sub n, a sub 1 times r to the power of n minus 1. This would be if you are dealing with geometric sequences and working with explicit functions. And there you go. It's color coded where this is the nth term, first term, common ratio, and the number of term in the sequence. Your Khan Academy assignments went over this concept here with some videos and practice. Okay. Take a screenshot of this or take a picture so I could change it to the next slide. Okay. All right. Angel, I'll be recording the lesson and post it on Schoology. Okay, so explicit gives the nth term directly. Here's a little example of arithmetic, and say the sequence is 2 and 6. But since you know that you're dealing with arithmetic sequences, you know that it has to be adding, right? So from here to here, I could see that I'm adding 4. I'm adding 4. So here you see that if you're creating your formula, 2 would be your first term, 4 would be your common difference, like the pattern, and then you just add a n minus 1. You multiply it times n minus 1. Versus geometric. Geometric has to do with multiplying or dividing. You see that from 2 to 6, it's times 3. So then on the formula, this looks a little weird, but let me rewrite it here. This would be 2 to the power of 3. I mean 2 times 3 to the power of n minus 1. That's what this little caret character means. It means raised to the power of n minus 1. Here, this is your f of 1. This is your first term. This is your common ratio. And then you raise it to the power of n minus 1. We also had a lesson where the 3 we use growth factor and the percent, right? This is where we learned about the percent and the growth ratio. Okay, I'm gonna change it, so write anything down that you need to write. Okay, recursive. So for recursive, a recursive function is a formula where each term is based on the term before it. Or you'll hear me say the previous term, and this is where you get this notation f parentheses n minus 1. That means previous term. Think about let me come up with an example here, like f of n, f parentheses n. Say you are an 11th grader right now. Okay, let's pretend you're in 11th grade right now. If you go backwards, that means that last year you were a 10th grader, and we denoted by f parentheses n minus 1. If you go back again, that means if you go back to the 9th grade, that was 2 years ago. So then the notation would be f of n minus 2. So f parentheses n minus 2, that means like 2 terms back. Same thing going forward. If you want to go forward and you want to write it like this, it'll be f of n plus 1. That would mean the next term over. Okay, so understand what this is, this, and this. Under recursive functions, you cannot say we have a list of numbers. Here's a list of numbers. If I ask you, if you know that the first number is 2 and you're under recursive, and I ask you, okay, class, what is this? What is this? What is this number? You can't figure that out on the recursive because you're missing this one. In order for you to know this one, you need to have known the one before, right? It's like saying you're gonna go from 9th grade to senior year. You can't go from 9th grade to senior year. You got to go from 9th to 10th to 11th to 12th grade. Okay, so that's the thing about recursive. Recursive, you need the one before. Under explicit, you don't. Under explicit, if I ask you, can you find this term here? You could find it right away under explicit. Well, we'll look at an example in a few minutes. We'll look at an example right here. Uh, Here's on the bottom here, there's it says recursive rule. Each term is found by knowing the previous term. And I forgot a little equal to here. This says the first term on the sequence is 6. So this would be like 6. The rule, this is your rule right here. And the rule is saying that you're going to take the previous number and add 4 to it. So if you want to know this number, the previous number was 6, so you're going to have to add 4. So it would be 10. And you'll repeat the pattern. You want to know this number? Then look at 10 and add 4. So that would be 14, and so on. And greater than or equal to 2, that means that you're starting to create the numbers from 2 and up, from the second term and up, because the first term was already given to you. You can't change the a sub 1 equals 6. That one is locked in. Moving on to the next slide. This is just a little review, recap of what I just said right now. When you are dealing with recursive, f of n is the term you're trying to find. F parentheses n minus 1, or f of n minus 1, means previous term. F of n minus 2, the wording is a little confusing here. But in my example, that was like 9th grade, right? How would you describe 9th grade if you are an 11th grader right now? So one way you might see it is the term before the previous term, or the year before the previous year. It's a little tricky to understand, but that's how you would interpret f of n minus 2. This picture is way blurry, but let me just show you what we have here. This is probably the most important slide here. So you have, let me explain what you're looking at here. You have explicit formula, and you have recursive formulas, and then you have arithmetic sequence, geometric sequence. If you are dealing with explicit formulas, this a sub n parentheses a sub 1 plus d times n minus 1, this would be the arithmetic sequence formula. Geometric would be a sub n a sub 1 times the common ratio to the power of n minus 1. Recursive formula, arithmetic, a sub 1, that's a number, but that represents the first term. And then a sub n is a sub n minus 1 plus d, the common, you're adding because it's arithmetic. So you take the previous term and you're adding whatever the pattern is. Oh, and something that is not here is the restriction of n greater than or equal to whatever number is next. And then geometric recursive, a sub 1, a sub n is equal to the common, well, the previous number, but now you multiply the common ratio, or the growth factor. Write that down, or save this slide right here. Now some examples. I'm gonna do two examples